The batteryless encoder. Sanyo Denki has finally done it. We no longer have to hook up a battery to get the multi-turn absolute position. We could always ignore the battery and do single turn absolute, but when you do multi-turn, normally you have to hook up the battery. But these guys have gone to figure out how to do it without a battery. This is a very high accuracy. I've used the 17-bit, but they do have a 23-bit resolution encoder. Resolution and accuracy are slightly different, so you have to check the accuracy on it. But usually the more counts, the better, up until a certain point that you can't go very fast because it's too big of a number for the velocity, 32-bit signed velocity register to handle. But it's your standard absolute A encoder. There's some interesting environmental operating temperatures, -20 to 105 degrees C. That's pretty good. Nice shock, nice vibe. So this all around pretty good encoder. Now when I first heard about this encoder, I had completely misunderstood the idea of it's not just a gear, although in this picture it looks like gearing to do multi-turn. That's what the Germans do. So like a Hengster will have a gear on it or precision gearing. But what this gear does is it generates a little voltage. So there's some gears in there. So when I turn the motor shaft, even when I'm not connected to the drive or I'm not powered by the drive, so I had to get this white paper from these guys to help really understand what's going on in here. But the basic idea is as you rotate the motor, you're going to get a pulse from a coil that passes a magnet, which is going to produce a voltage, which is going to power a chip, which is going to store the rev to the non-volatile memory. So in the flash, you're going to write the flash every time you turn the motor shaft. So that's the basic idea there. And I've got this motor, and I've connected to a drive, but I don't have the power turned on. So I'm going to rotate the motor shaft 3, 4, 5, 6, 7, 8, 9, 10 revs, and it should have an absolute multi-turn position when I connect to it. So let's take a look at that here. Just the basic configuration. I am using a Zenith Compact. It's a Zenith Plus compact drive, plus because it reads the absolute A encoder. I've got the Stowe bypass jumper. I've got the 24 volts. You could have a brake connected here too. I've got the motor power wires connected for the 3-phase brushless motor. I've got the serial connection, and I've got the feedback device connected with the red and black for power and the brown and blue for the serial data. We'll take a quick peek at that in the data sheet here. So I've got this R2AA04005 motor, and it's got all the motor constants, inductance, resistance, back EMF, continuous, peak torque. It's a 200 volt AC motor, so I can get pretty fast with 120 volts AC, but this drive can take 240. And I have a blue wire. So just to check out the wiring of the absolute here. So red and black, 0 and 5. And here's the old pink and purple. That was the battery. You don't need that anymore. Just use the blue and the brown. Data plus and data minus. Bidirectional serial communication hooked up to S and S not on the coupler. So that's the basic thing there. Now I'm going to use CME2 version 7.1. I got the latest beta here, but we're going to connect to this drive and take a look at the, oh, I got to turn the power on. Got to have 24 volts. Should have a green light. Yeah, green flashing. If I had a red light, that's because I didn't hook up the AC power. So let's try connecting again. Just connecting over the serial port using the USB to RJ11 there. Take a look at the basic setup. So it's a brushless rotary, absolute A. I'm going to do position can, that's fine. Emulate it out. We can emulate that 17 bits of absolute. Sanyo Denki, motor data entered. I got 17 bits, 131,072 counts per rev. That's good. Number of revolutions, 65536. Doing it at 2.5 megahertz. And I don't need to ignore the battery because it's battery less. So I'll get multi-turn information on power up or reset, which is good. So we're going to take a look. I just turned the power on, and look at that. I rotated the motor 10 times without the power connected, and it knew the position. So it used that little gear it's got. It's a slightly bigger case on the bottom. It's just not that much bigger, a little rounder, I think. Maybe a little bit longer, but it's got a gear in it, and it generates a voltage that is produced by a coil past a magnet, and then it stores to the chip in here as a flash chip, and then we read it. So we can do return back to the 0 position here, and I'm going to hit it with a trajectory, and now I'm back to the 0 position. And again, you know, I can move it to the 0 position, but what if I want to do some homing? Well, we can do that too. Right now, you can see on the control panel, home is not referenced. So if you have some other homing routine in here and you want to get back to normal and to calibrate, well, set current position as home and don't do anything with it. Don't push any buttons, don't home. And on power up or reset, the drive will read from the feedback device its absolute position. So let's say that this is not the position I want to be in for calibration. Maybe I want to wind it down to the end, and I go, all right, now I'm going to attach my motor to my system, and I want this to be 0. Well, there's a method for doing absolute encoder immediate home, where if that's the position I want, and I'm currently at this other position, so I'll go minus 226922. So that's my new 0 position, because I add these two numbers up. Now, again, I started off with not running a homing routine, but now I'm going to run it. Home reference calibrated, that's good. And you can see on the control panel, home is referenced, and I'm at the 0. Now if I reset this drive, it's going to read the value from the encoder, the positive 200,000. It's going to subtract the 200,000, the absolute immediate home, and then I'll be referenced to that position. So, oh, I'm not referenced yet. Why is that? Home. Oh, I need to save that to flash. So let's try again. Absolute immediate home. Minus 226922. Save to flash. Now home. Okay. Exit. Let's reset it. So, the encoder tells the drive its absolute position. Multi-turn. The drive subtracts the correction factor, and now it knows where 0 is. So 0, it happens to be in this position. But I could power up in some other position. You know, maybe I power up here and reset the drive. And you'll see, you know, the actual position should be about the same after the reset. so I know where the 0 position is. Here we go. Powered up. And let's go to 0. So move back to 0, and that would be the 0 position that we calibrated in the system. Again, if we want to redo this, we have to be smart about it. So get rid of the absolute calibration, get rid of the offset, save it to flash so you can reset it, home it, good. There's the 0 position. So when I power up or reset, it's just purely the absolute position reported from the feedback device. No calibrations, no offsets. And so now we can see, yeah, there it is. No homing reference, and that's the position reported from the encoder. So, go back and do the absolute immediate home. Move it to where you want to move it. Put in the correction value here. Save it, and then execute the home and reset the drive for a test, and you'll see that it works. All right, well, thanks for watching batteryless Sanyo Denki motor encoder.